Configuration Manager, and Network Access Protection. So if you haven't played with network access protection before, I think you're going to find this particular nugget to be a little bit more difficult than some of the nuggets we've talked about. And it's not necessarily because Configuration Manager adds complexity to the concept of network access protection, but the concept of NAP itself is somewhat complicated. And in this nugget, we're going to talk about NAP. We're going to talk about really what network access protection is attempting to do. We're going to talk about the different types of NAP and how, based on the type of protection that you want for your network, there are a lot of different options for you. And then once we sort of understand what network access protection is and how it can work with your environment, then we'll talk about how Configuration Manager works inside of that NAP infrastructure. As you'll find out, one of the prerequisites for using the NAP components of Configuration Manager is to first have a NAP infrastructure set up and in place. And depending on what sorts, again, of protection you want, that can be a relatively easy thing or a somewhat difficult thing. We'll talk about those prerequisites and what you need, and then we'll also talk about the installation and configuration of the Configuration Manager components of NAP. Really, the hard part is getting the NAP infrastructure set up first, and once you've done that, adding in Configuration Manager is not terribly difficult over the top. And then we'll talk about what the capabilities are when you integrate these two technologies together. Now first, a little disclaimer, because this isn't necessarily a video series that is supposed to be about network access protection. No, this is a video series that talks about Configuration Manager. So we'll talk sort of in some generalities about network access protection, but if you plan to implement this technology in with your Configuration Manager infrastructure, you're going to have to do some research and learning about the NAP infrastructure first. Let me help you out, at least at this point, with understanding what NAP is by giving you a very simplistic example. You'll see here that I've created a Windows domain, more or less, and that domain is connected up here to the internet, and between that domain and the internet is some sort of firewall. Maybe this is the most expensive, most powerful firewall ever invented in the entire world. And our domain, anytime anybody in our domain, any computers in our domain, attempt to go to the internet to download content or to do whatever they need to do on the internet, it is protected from this massive, powerful firewall. Well, in this case, we're relatively protected when the computers on our domain attempt to connect up to the internet, because this massively powerful firewall is here protecting us against ourselves, more or less. But even the fastest and nicest and most powerful firewall in the world can't solve the problem when a rogue laptop more or less connects right into that domain. When a rogue laptop walks in the door and plugs into the most available network port, that firewall, no matter how powerful it is, really can't protect what's on that laptop from maybe infecting the rest of the domain. And now that's really what NAP is designed to do, is if you have these situations where you have computers that are coming on and off the domain, these computers are given a sense of health. And that health is actually monitored by the NAP infrastructure. And if a computer is considered healthy, then that computer is given access to the production domain for doing whatever it needs to. If that laptop is not considered healthy, or whatever computer is coming into the domain, then it is given limited access. It is put into more or less a remediation network or a special network where it is then fixed, it is updated, the patches are put on, the firewall is turned on, all the things that need to occur to make it comply with the health requirements of the domain. Once that's done, then that laptop then gains full network access. The idea here is, again, if you have this super powerful firewall that's protecting you from the internet, you don't really have any protection against these laptops that just plug right in and walk right in the front door. And so what NAP does is that gives you an extra sense of security when you have the situation where those laptops are coming in. We're going to talk about how you actually install NAP and how you can actually configure NAP through a number of different enforcement mechanisms. Each one is a little bit more difficult to use and more difficult to install, but each one provides greater levels of security for these situations where these laptops come on your network. Now, before I show you the server side and actually setting up network access protection, let's actually take a look at what the client side of network access protection looks like. This is our old friend Nugget 1. This is the Windows XP computer that is inside of our Nugget Lab domain. And Nugget 1 is currently updated to Windows XP Service Pack 3. The network access protection components are available in Windows XP Service Pack 3, and they're also available as part of Windows Vista and also Windows Server 2008. And so no matter what sorts of operating systems you have in your environment, you can make use, as long as you're at least Windows XP, you can make use of the network access protection components. You'll see here that I've brought up the network access protection little wizard here, which gives us some information about whether or not we are compliant with the requirements of the network and if we have full network access. We can bring this up at any point by going to Start, Run, and then using the command napstat. Napstat will actually bring this tool up so we can take a look at it. Right now, our computer is compliant with the requirements of this network because I have a security policy in place that says that the firewall must be turned on for all the computers in my network. And this laptop currently has that firewall turned on. You'll see I have a network connection here to my nuggetlab.com domain. I have the correct IP address. And if I go here to Start and then Control Panel and then look down at the Windows Firewall settings, you'll see that the Windows Firewall is currently turned on for this computer. Now, there's a lot of different things that I can do to verify the security and health of the computers that are plugging into my domain. I talked about anti-spyware, there's antivirus, there's firewall settings, and making sure that they're all up to date as well is very important. Now, in this case, the security policy that we've set is that that firewall must be turned on. If in any case a laptop is coming into our network or is already in our network, and for some reason the user decides to turn off the firewall or turn it on before they brought that computer in, if they go and click to turn off that firewall, well, they're no longer going to be compliant with the policies of our network. If I click this off button and click OK, you'll see that, well, wait a minute, the firewall's not turned on. Well, pretty soon here, NAP is actually going to take over and say, well, wait a minute, your computer is no longer compliant with the requirements of this network. My network access has now been limited. You'll see here that if I look, the network access will be limited until the computer is updated. In other words, because the firewall was turned off, network access protection has said, whoa, wait a minute, you're not meeting our security policy. And you're not meeting our security policy, which in this case is that a firewall program is turned on and enabled, well, you're not going to get the access to the production network like you need. When that occurs, we are actually taken to a different network. You'll see if I switch back to my command prompt here, before I was actually connected to the nuggetlab.com DNS suffix. If I actually do an ipconfig again, you'll see that I'm now actually connected to the restricted.nuggetlab.com DNS suffix. You know, the IP address is the same here because of the way we're setting up this demo, but what you can see here is that network access protection has the ability to move the computer from one location to the other, to change the IP address, to change the suffix, to change, in this case, the default gateway from having an 0.1 connection to no connection whatsoever, to put it in another location where that computer can then be remediated. Once that computer has been remediated, then we bring it back on the network and then everyone's happy again. If that user were to resolve the problem, for example, if they were to go to Start and Control Panel and then back down to the Windows Firewall again, if we go back to that Windows Firewall Control Panel and we turn the firewall back on again, as soon as we turn that firewall back on again, network access protection will recognize that the firewall is turned on and put us back into that correct network as necessary. If we click the Try Again button here, you'll see that eventually network access protection will recognize that we are correctly on we have the correct security settings that are necessary for our network, and once that is completed, we'll be given full access again to our network. And there you'll see now that the computer is once again compliant with the requirements of this network, and so we have fully brought ourselves back to a level of health that is appropriate for the security settings that we've set for this network. If I go back to the command prompt here and do an ipconfig once again, you'll see that the DNS suffix, just as we set before, will leave the restricted zone and take us back to the regular nuggetlab.com DNS suffix. And so this is a good example of showing you network access protection and how it can protect you against those laptops as they come on and off your network, so that when they come on the network, they can be checked for their security settings, and in some cases actually be automatically remediated. If they're missing patches, if they're missing the firewall being turned on, for example, they'll actually automatically get that setting reconfigured so it's appropriate for your security settings. Now, in order to do this, there are actually 5 different ways of doing enforcement of this security policy using network access protection. The first of which is the one that we're actually using for this demo, called DHCP enforcement. In this case, what we're saying is when a laptop attempts to come onto our network, or when a computer attempts to request a DHCP address of any kind, the DHCP server will work with the network access protection server to determine the health of that machine. If that machine has a clean bill of health that is completely completely healthy based on the security policy, then it will get a DHCP address. If it doesn't, it will not get a DHCP address, or it will be given an address in another network where it can be remediated or fixed. This is a great form of NAP enforcement because it is relatively easy to set up. However, there are some problems because if a user goes and manually sets their IP address for their computer, they can get around the enforcement. So while it's very easy to set up, it's also pretty easy to get around too. We have VPN enforcement, which is for users that are coming in from their home machines or their machines when they're out on the road. We can actually determine whether or not they're healthy before they're allowed to VPN into our network. If we're using terminal services in Server 2008, we can use the terminal services gateway as another mechanism for enforcement. Before those machines are allowed to make a terminal services connection, the same process goes through where they're checked for health. If we have 802.1x support for our network infrastructure, before we actually open up the port, the physical switch port for that machine, then we'll do the health check on those machines. And this will actually have to integrate in with our switch infrastructure for this to be able to work. And then lastly, we have IPsec, which uses health certificates. And these health certificates, again, before that machine is allowed to communicate with other computers in our environment, IPsec and NAP will look at that computer, verify its health, and make sure that it is healthy before it's actually given that ability to connect in. So you can see here that there's a lot of ways of deploying NAP enforcement in your environment, depending on the level of complexity you want and the level of fulfillment that you want to validate that all those machines are capable. Now I'm going to show you actually what this looks like, the NAP infrastructure looks like here in a second, but before I do that I want to talk a little bit about the different components that you're going to see when we take a look at our NAP infrastructure. We're going to have what we call a connection request policy first, and this connection request policy is actually used to determine where do we actually process incoming requests. In other words, do we have those requests processed locally, or do we use another Radius server or Radius client out somewhere in our environment? Maybe it's a different DHCP server out somewhere, or maybe it's a different server that handles those requests. This connection request policy determines who actually processes the system health information. We have a network policy, and this network policy actually designates who can connect to the network and under what circumstances. Are they compliant? Are they compliant to some sort of health requirement? If they are, what kind of network do they get access to? If they're not, what sort of network access do they get access to? Is it a remediation network, or do we just watch to see where they're coming in and just monitor whenever they're arriving, whenever they're not healthy? If the server or the workstation that's coming on the network does not have the necessary prerequisite components in place, maybe they're at XP Service Pack 2 instead of Service Pack 3, what do we do with them in that case? This allows us to choose what sort of networks that we provide to different users based off of where they are in terms of the ability to fulfill our health requirements. The health policy here actually connects this network policy to what we'll talk about here, which is the system health validator. But essentially, this is the logic that tells the NAP infrastructure when to apply what system health validator. Does it pass the health components or the health tests? Does it fail one or more of the tests? Does it not have the capabilities in place? The most important of these really is the system health validator, which actually identifies what the security policy is for our environment. Is that policy that we have to have the firewall turned on? Do we have to have anti-spyware turned on, and does it have to be up to date? Do we have to have antivirus turned on, and does it have to be up to date? The system health validator is really your determination of what you consider healthy. Now let's actually take a look at what these look like inside of our NAP infrastructure. I'm going to go ahead and minimize this and bring up our network access protection server here. And you'll see that on this NAP server, we've actually created it as a DHCP server and as a network policy and access services server as well. These are the two components that we need in order to do DHCP enforcement. We've created a scope here, an IPv4 scope for the Nugget Lab that we've created. There's a couple of addresses in this pool, and we also have a few options that we've created as well. You'll see here that we have two options that we've created, one for Nugget Lab and one for restricted.NuggetLab. You'll see here that we have different classes that we can create. One is the standard class, and one is the default network access protection class that we have. And then what this allows us to do is say, for our default, our production network, we can create our production network, and here is essentially our production DNS suffix, or maybe some production IP information. We have also the restricted class here that occurs whenever network access protection deems us to not be fully healthy. In that case, we can actually give them, in this case, just a different DNS suffix. And so this is the DHCP component of this. We also have the network policy and access services component of it as well. And this is the NAP components. This is the NAP server portions of what we're trying to do. We talked about the connection request policies here. You'll see that we have a connection request policy here called NAP DHCP. This connection request policy is using DHCP server enforcement as the mechanism for determining when our clients are actually compliant with the health policy. The conditions here say more or less at all periods of time is this policy in place, and when this policy is in place, what are we attempting to do? Are we attempting to authenticate requests on this server, forward requests to a following radius server, or accept users without validating credentials? Once we have determined whether those users are going to be authenticated locally or through another server, then we roll down to the network policies node to determine, first of all, are they compliant? Then are they non-compliant? Or possibly are they not even capable of actually understanding the NAP infrastructure? Let's take a look if a situation occurs where a system is non-compliant. If a system is non-compliant, we are going to give it the access to actually log in, because we don't want to deny them the access to actually connect into our infrastructure, because we need to remediate them. If the DHCP server deems them non-compliant because the health policy has deemed them as non-compliant, then what we want to do is actually here under settings, under enforcement, allow them limited access to our environment. This limited access says to the DHCP server, okay, put them in this limited access environment and give them the ability to auto-remediate. You'll see down here we have the ability to enable auto-remediation of client computers. The network access protection infrastructure knows what is wrong with that computer. And when it knows what is wrong, it knows what it needs to do to bring that computer back into health based on the security policy that we've created. We can also create a remediation server group here, a domain services remediation server group, which has the power, using group policy or using other mechanisms, to actually instruct the client what to do. If we have a web page that we've created ourselves, we can even specify a web page address that will provide instructions to that user, letting them know what's going on with their computer. You saw the little balloons that popped up on our client whenever the client was going through the determination as to whether it was compliant or not. Well, we can also provide that URL to our users to let that pop up and instruct them what's going on so that they don't end up telephoning our help desk whenever a problem occurs. The most important of these really is the health policy. And these health policies here determine whether or not the DHCP, the client is compliant or non-compliant whenever they're connecting into the DHCP server. You'll see here that it is using the security health validator. When it passes all of those checks, we then deem it compliant. When it does not pass all those checks, when it fails one or more of these checks, then we deem it non-compliant. And so this is the tie between the health validator and all of the other functionality to let it know when things need to occur. Very last down here, we actually have the system validator itself. And this is the part that I think you'll find the most interesting, because this is actually where we determine what we consider to be healthy. There are a number of error modes and how we determine what is considered compliant when we see different error modes. Perhaps it's unable to contact services or it's not responding. But what we see when we click the configure button here is all of the necessary elements that we want to ensure are in place before someone is considered to be compliant. You'll see here for Windows Vista, under Firewall, we've chosen that a firewall is enabled for all network connections. What this says is that if a firewall is not enabled, we do not consider that client to be compliant with our security health validation. We can choose antivirus, we can choose anti-spyware. For either of these, we can ensure that antivirus or anti-spyware is up to date. We can ensure that automatic updates is enabled. If all these are the case, then we will consider ourselves to be compliant. If any of those are not the case, then we are not compliant. The same thing holds true for Windows XP. Firewall, virus protection, automatic updates, etc. So all of these pieces fit together for us to be able to scan those clients and determine if those clients are healthy. Now, all of this up to this point has absolutely nothing to do with Configuration Manager. This is just the NAP components that you need to have in place before you can ever do anything with Configuration Manager. For you to actually do things with Configuration Manager, we have to have that NAP infrastructure in place. That's one of the prerequisites. We have to have it in place, and we also have to have the enforcement mechanism that we want for our environment enabled. We have to then, once we've enabled all of that infrastructure, then we go into Configuration Manager and actually enable our System Health Validator point. I'm going to show you how that's done actually here in a second. We also have to make sure that we have the Active Directory integration between Configuration Manager and the NAP infrastructure in place. We have to have the schema extended, we have to have the container created in Active Directory, and we actually have to be pushing data to Active Directory from our Configuration Manager infrastructure. We've already done that way back in one of the earliest nuggets when we did the install of Configuration Manager. We created this integration components already. So we've already have this in place. The last thing that we need to do then is determine the software update policies. What you're going to find with Configuration Manager and the Configuration Manager integration with NAP is that what we are doing with Configuration Manager is determining which of the software updates that we talked about in the software updates nugget, which of those software updates need to be on a client for it to be considered healthy. We're not going to worry about firewalls here. We're not going to worry about anti-spyware here. We're worried specifically about which software updates are installed on that computer for it to be considered compliant. So let's actually take a look at our Configuration Manager server here and see how we can actually enable the Configuration Manager components so that Configuration Manager will work with NAP. In this case, we've already configured our NAP infrastructure. We've already done all the things we need to set up the infrastructure, to set up the enforcement. For this to work, we actually need to install Configuration Manager onto a Windows Server 2008 server that has the NAP components installed. The Configuration Manager components that we're about to install don't function at all if they're not installed on Server 2008. Now, in the case of this demo, our Configuration Manager is installed onto Server 2003, and this will give you an idea of how it looks, but you have to have this installed on Server 2008 for it to function. The first thing you need to do here under Site Systems is actually install the System Health Validator point. And you'll see I've already done that. I've already done that because there are no options that are needed in order to install that System Health Validator point. You can install this to really any number of primary servers in your environment, but they're all going to more or less do exactly the same thing. You're going to have one NAP infrastructure for your domain, and so you're going to have all of the System Health Validator points more or less with the same data. Once you've installed that, you actually can then configure it through component configuration. You'll see here we have System Health Validator point component. If we double click this, what we're going to see at this point is how often are we going to query Active Directory for System Health Validator information, for those health state references that we talked about. In other words, whether or not the client is healthy or not. And then also, how many hours are going to go by for client statements of health to actually be valid. In this case, the default is 26 hours in this point. Also, do we use UTC as an option for us as well? Under here in the Health State Reference tab, we can choose which Active Directory for us is actually going to store the health state information for our clients. Now remember, that health information is actually stored inside of Active Directory, and so the System Health Validator point is more or less going to query Active Directory for the information about the clients to determine whether or not those clients are healthy or not. So there's really not a lot here that you'll actually be configuring for that System Health Validator point here within Configuration Manager. The vast majority of the configuration is done within Network Access Protection. Now, once we've done this, then we can actually go through to our Network Access Protection node here and create policies for Network Access Protection. What these policies do is identify which of the updates, which of the particular software updates that we want to be enforced by our NAP infrastructure. If I right-click here under Policies and choose New Policy, I can create a new policy and identify which of those bulletin and article IDs are important for NAP evaluation. If you look here, there are only 4 here because these are the 4 policies, usually these are the 4 articles that we've set up in a previous nugget for being deployed by the software updates. In other words, these 4 in that previous nugget we've set up to be installed by Configuration Manager as software updates that we are monitoring inside of our infrastructure. We can also here identify that not only do we want these to be pushed out through Configuration Manager, but we also want them to be enforced by Network Access Protection. If I click Next here, you'll see that we can specify when these policies become effective, either as soon as possible or after a particular date and time. Once we set this up, now we will have at the same time software updates pushing these and also Network Access Protection enforcing that those have to be on our clients. Let me click Close here. You'll see as soon as I do this that we now have those bulletins available in Network Access Protection, and Network Access Protection is now going to monitor for the installation of those updates for a client to be considered compliant by Network Access Protection. If you go back, remember when we were talking about our client, when we were looking at Nugget 1, and Nugget 1 was saying, well, the firewall's not turned on, so I'm not compliant. Now, if these updates are actually not installed on our client, then that will not be considered, that client will not be considered able to connect into our production network. If I go up here into Software Updates, you'll see that the update list that we've created here, this update list was what we created back in our software updates nugget. The same 4 updates that are in this software update list are the ones that are now being enforced by network access protection. But we don't necessarily need to go down into the network access protection node to actually set which of these updates we're going to monitor through network access protection. If we look at any of the updates in our update lists or in our collection of update lists, we can right click and choose properties of any of those updates and choose the network access protection evaluation tab here. What this allows us to do is enable or disable the evaluation of whether that update is on our system as part of the NAP infrastructure, and also change again when those policies become effective. Now you got to be careful with these dates. If you actually deploy out a bunch of patches and don't give your infrastructure enough time to update the patches, and then you go back and enable NAP evaluation based on those patches, you may have some clients that, or maybe a large number of clients that necessarily haven't gotten that patch already installed. And so you got to have a little bit of time between deploying out new patches and then requiring that those patches are actually deployed on clients, because otherwise your clients are going to come in, they're going to go into that remediation network, and they're going to have to spend some time actually getting remediated, and it can be a problem or a time delay on the part of your users. So be very careful about when you go through the process of enabling NAP evaluation for the clients on your network. But we don't necessarily need to go down into the network access protection node to actually set which of these updates we're going to monitor through network access protection. If we look at any of the updates in our update lists or in our collection of update lists, we can right click and choose properties of any of those updates and choose the network access protection evaluation tab here. What this allows us to do is enable or disable the evaluation of whether that update is on our system as part of the NAP infrastructure, and also change again when those policies become effective. Now you got to be careful with these dates. If you actually deploy out a bunch of patches and don't give your infrastructure enough time to update the patches, and then you go back and enable NAP evaluation based on those patches, you may have some clients that, or maybe a large number of clients that necessarily haven't gotten that patch already installed. And so you got to have a little bit of time between deploying out new patches and then requiring that those patches are actually deployed on clients, because otherwise your clients are going to come in, they're going to go into that remediation network, and they're going to have to spend some time actually getting remediated, and it can be a problem or a time delay on the part of your users. So be very careful about when you go through the process of enabling NAP evaluation for the clients on your network. Obviously, once you've got this all in place, the last thing you need to do is really report on what sorts of activity is going on in your network based on network access protection, and all of that's done just like everything else here within the reporting node. If we click down to the reporting node and expand and we look at reports, you'll see that there are a number of network access protection reports that allow you to see the success or failure of network access protection in your environment. We can see the list of computers that can be updated to support NAP, the remediation failures, those non-compliant computers, and any summaries of non-compliant computers. We can even list the network access protection policies here and just see what sorts of policies that we're actually attempting to run in our environment. You'll see here are the 4 policies that we have set based off of these article IDs, based off of these updates, and then also when the effective date is for those as well. And so you'll see here that this allows us some sense of understanding what the success is of using network access protection in our environment, and then how many computers are coming in that may be non-compliant. Remember, there are ways within network access protection, within the NAP components, of not necessarily telling the clients they can't come onto the network, but just monitoring for how often clients that are not compliant are coming in and off of our network. And so before we actually enforce any changing of networks and any remediation networks, it may be of interest to you to just determine, well, how often are non-compliant computers coming in and off, on and off your network? It may give you some sense of really how insecure you may be within your environment. And so NAP actually gives you that ability again to really further secure your environment from those computers as they're coming on and off the environment, and give them an opportunity to come up to your sense of health, so that that sense of health gives you a better secured environment against computers that may be out in the world and coming back into your domain. So what have we talked about in this nugget? We've talked about Configuration Manager and its connection in with network access protection in our environment. We did a pretty lengthy explanation of network access protection and how it works both at the client and at the server level. And we talked about those 5 types of NAP and how, depending on what level of security you may want to implement one of those different types. And then we talked about how you can combine NAP with Configuration Manager, not only from the prerequisite standpoint, but also the installation and configuration, and also what capabilities Configuration Manager provides to network access protection. I hope this has been informative for you, and I'd like to thank you for viewing.